Hi everyone. Today I wanted to talk to you about the basics of using the vertex to solve problems and then discuss a little bit about shifting and scaling of functions. So we're going to start by considering this situation where Jack throws a baseball. So the function that we're given tells us the height in feet that the baseball is above the ground, where x represents the distance that the baseball is from Jack. So the first thing we want to figure out is how far from Jack is the ball when it reaches its highest point on its flight. Well, if we draw a picture of the situation, Jack is going to take this ball, throw it into the air. Eventually it is going to hit the ground, maybe kick up a little dirt. Okay, so our picture looks about like this. So if we want to figure out how far the ball is from Jack, we are looking for this horizontal distance x when it reaches its highest point on the flight. So we are looking for the x value of the vertex of our parabola. And we know that x value is given by negative b over 2a. So for our situation up here, we have an a value of negative 0.0013, a b value of 0.26, and a c value of 5. So this is going to give us negative 0.26 divided by 2 times negative 0.0013, and working that out is going to give us a value of 100. So what that means is that that ball was 100 feet away from Jack when it reached its highest point. So if we want to figure out what is the highest point it reached, then we're going to plug this 100 in for x into our height function, which will give us a negative 0.0013 times 100 squared plus 0.26 times 100 plus 5, which is going to give us a value of 18 feet. So the highest height reached by that baseball is going to be 18 feet in the air. So this is the point of the vertex of our quadratic. And that is going to allow us to solve the next part. We want to put this into vertex form. Well, the vertex form and the standard form model the same function, so we know that the a value is going to be the same. So the a value is still going to be a negative 0.0013. We now know that the h is going to be the x value of our vertex, which is 100. The k is going to be the y value of our vertex, which we found to be 18. So our vertex form is going to look like f of x equals negative 0.0013 times the quantity x minus 100 squared plus 18. And I just want to briefly discuss how this function was created from our standard quadratic of x squared. What we can see here is that it was shifted to the right 100. This would shift it up 18. Multiplying by a value less than 1 is going to vertically compress it or make it flatter, and then that negative out front we know is going to reflect it across the x-axis and make it face downwards and have a maximum. So next we want to figure out how far from Jack does the ball hit the ground. Well, if the ball is on the ground, then the height is 0, so we're going to let the left side of this equation be 0, and we're going to use the vertex form to solve this because it's going to be easier. So setting this up is going to read 0 equals negative 0.0013 x minus 100 squared plus 18. What we want to do is isolate the square part first. We'll start this by subtracting 18 from both sides. And next we'll divide by the negative 0.0013. At this point we're left with 13,846.15 equal to x minus 100 squared. We are looking to solve for x, so at this point we'll go ahead and take the square root of both sides to get rid of the square. On the left, we do get two values, one positive, one negative. And on the right, again, that square and that square root are going to cancel, just leaving us with x minus 100. So our last step to solve for x is to add 100 to both sides. So we will have two solutions here. One will come from 100 plus the square root of 13,846.15, and the second one will come from 100 minus the square root of 13,846.15. So let's go ahead and find those two values. So algebraically, we have two solutions to this equation, 217.7 and negative 17.7. But our question was, how far from Jack does the ball hit the ground? So we know our answer is going to be this positive value, 217.7 feet away. Regard that negative value for this applied problem. In case you were confused about why we got two values, anytime we take the square root of both sides of an equation, we are going to get a positive and a negative value, and here's why. So if we started with x squared equals 16, and we take the square root of both sides, we will get two values of 4 and negative 4. 4 squared is 16, negative 4 squared is also 16, so we do have two solutions here. Lastly, for this problem, we want to find the intervals of increase and decrease for this parabola. So remember that our parabola looked about like this, and we found that the vertex occurred at the point 118. In order to find the intervals of increase and decrease, remember we always give intervals in terms of our x values. So our function is increasing all the way up into an x value of 100, and after that point our function is decreasing. So our function is increasing all the way over here from an x value of negative infinity all the way up to an x value of 100. And from 100 all the way to infinity, our function is decreasing. And this is just a reminder of the different ways that our quadratic functions can be written. Standard form is ax squared plus bx plus c. Vertex form is a quantity x minus h squared plus k, where the vertex is hk. And we can also write it in factored form, where we have a times x minus r1 times x minus r2, where r1 and r2 are the zeros, in other words, the x-intercepts of our function. So this leads us right into discussing our shifting and scaling. And here's just a refresher of everything that's going on. So if we have f of x minus h, that's going to be a shift to the right if h is positive, if we have x minus h, and a shift to the left if h is negative, and that would read x plus h. F of negative x is going to reflect us across the y-axis. F of a times x is going to be a horizontal stretch or compress. We don't deal with that a lot, but just so we know what that looks like. F of x plus k is going to be a shift up k if it's positive. It's going to be a shift down k number of units if k is negative. Negative f of x is going to reflect us across the x-axis, like the parabola in our last problem was. A times f of x is going to be a vertical stretch if a is larger than 1, a vertical compression if a is between 0 and 1. So let's see what we can do with the following problems based on that. So we want to shift the square root function to the left 22 and down 15. So we're going to write it generally at first, and then we'll apply it to our square root function. F of x plus 22 minus 15 would shift any function to the left 22 and down 15 units. So in particular to our square root function, if we replace the x with x plus 22, that's going to give us the square root of x plus 22 minus 15, which would shift that square root function left 22 and down 15. For the next problem, we want to apply a series of shifts. And so we're going to start with our reciprocal function, y equals 1 over x. So the first thing we want to do is shift right 3 units. So for any function, that would be f of x minus 3. So we're replacing the x with x minus 3. So 1 over x minus 3 would shift that reciprocal function to the right 3 units. The next thing we want to do is shift what we just made up 9 units. And to do that, we would take any function and just add 9 to the outside. So for our function that we had here, we had 1 over x minus 3. Shifting that up 9 units is going to be plus 9 on the outside of our function. The last thing we want to do is take this function that we just created and reflect it across the x-axis. To do that, we're going to take the opposite of our entire function. So taking the opposite of our first term is going to give us a negative 1 over x minus 3. And the opposite of our second term is going to be minus 9. So a negative 1 over x minus 3 minus 9 is going to have all three of those shifts and reflections applied to it. The next thing we're going to do is consider this function, f of x equals 2x squared minus 3x plus 1. We are going to evaluate and simplify the expressions. And we're also going to discuss the transformations that took place. So the first thing we want to do is take negative 4 times f of negative x. And we can set this up in steps. So we know we're going to multiply everything by negative 4. And the next thing we're going to do is replace all of our x values with negative x. And from here we can simplify. So let's start by simplifying within the parentheses. If we take negative x and squared, it's going to be positive, so that's still going to leave us with positive 2x squared. This double negative here is going to make that a plus 3x and plus 1. So after we distribute this negative 4, we will have our final answer of negative 8x squared minus 12x minus 4. Negative 8x squared minus 12x minus 4. To discuss the transformations that would have taken place here, this negative inside of our function would have reflected us across the y-axis. This negative outside of our function would have reflected us across the x-axis. And multiplying by 4 would give us a vertical stretch for our function. So with the same function, we're going to consider f of x minus 3 minus 5. So what we know is that since we have f of x minus 3, we are going to replace all of our x values with x minus 3. We're going to tack on this minus 5 at the end. So initially, this entire first part here is f of x minus 3 and minus 5. In order to simplify, we are going to have to FOIL this first parentheses here, and we will have to distribute for that second parentheses. So remember that x minus 3 quantity squared really means that we're going to take x minus 3 twice. Distributing is going to give us a negative 3x plus 9, and combining our last two terms would be minus 4. So if we FOIL here, we are going to have x squared minus 3x minus 3x plus 9. And at this point we will need to distribute the 2 to everything in our parentheses. And our last step to simplify is going to be to combine like terms. So our final answer for this problem will be 2x squared minus 15x plus 23. And lastly, we will discuss the transformations that took place. So replacing x with x minus 3 is going to give us that shift to the right 3 units. Having this minus 5 is going to shift our function down 5 units. I hope this helps.